All right, we are back starting at Unit 2. Now, some of the things from Unit 2 or that we need for Unit 2, we're going to have to review things like factoring you've learned in Math 1 and 2. So some of those things are going to be coming back, but we're going to review them pretty quickly. So if you need additional practice with them, please see your teacher. Make sure that they are that you understand everything that you're covering. You may also be going back and using some things that we did in Unit 1 when we talked about piecewise functions, absolute value functions, and some of those same things with graphs. So where is it increasing? Where is it decreasing? Where does it hit the x-axis? Where does it hit the y-axis? All things like that. So please remember all those things that we have taught you before, as well as previous math courses. All right, so we've done something like this before, but let's review over this with our warm-up. So here, you've got to find h of 4. Just make sure you're using h. We're going to say h of 4. All right, I'm going to do that separately. And 3 times 4 minus 4, like that. All right, now, if you're like, oh, I have no idea, I can't do this, whatever, you are welcome to plug in h of x equals 3x minus 4 into Desmos. And if you want to find h of 4, you can do that right there. Here, or you can plug it into your calculator. 3 times 4 is 12, minus 4 is 8. And you can see that it says 8 right here on the calculator. All right, so we're going to do 3 times 8 minus 2 times. Okay, now G. All right, again, if you don't understand G and how to plug this into X, all right, and you don't know that to find G of 5, we're plugging in, whoops, don't put 3, sorry. You got to make sure you're writing down G. So it's going to be 2 times, it's 5 squared, all right, plus 5, like that. And you can plug that in your calculator. Some of you can do it in your head, but if you can't, plug all of this in. You got to make sure you do an equal sign. Okay, and now if you say just G of 5, guess what? You've got it. All right, and that comes out to be 55. All right, so now I've got to actually plug this entire thing in. 3 times 8. Whoops. All right, 3 times 8. All right, minus 2 times 55, like that. And we get negative 86, all right, as our answer. So let's go on and do number 2. Now, what do you remember from last unit? All right, we talked about inverses. Well, what does inverses mean? Inverses mean we switch x and y. So what I'm going to do is I'm going to switch it. I'm going to say x equals 3y minus 4. And now we solve for y. All right, add 4, x plus 4 equals 3y, and divide by 3. Now, you could write this out multiple ways. We could say the inverse of h equals, all right, you can leave it as this x plus 4 all divided by 3. You can also do x over 3 plus 4/3, like that. That's another way to write it as well. Now, if you're checking it, we can go to our calculator, all right, and we can check it. Clear everything out. Put h of x in. H of x equals 3x minus 4. And then remember, it reflects over the line of y equals x. All right, so my answer, when I plug it in, I'm going to plug in x plus 4 in parentheses and then divide the whole thing by 3. Does it look like it reflected over that blue line? And it did. Okay, the line y equals x. So don't forget about inverses. Now, the thing I told you that you're going to have to remember is factoring. We're going to run into a lot of things with factoring. So let's talk about this first type of factoring here. GCF, greatest common factor. You're pulling out GCF here. What's alike? Okay, so 15x to the third minus 25x. Look at the numbers, 15 and 25. What goes into both of them? All right, 5. That's the biggest. All right, but then also look, each of them have an x. All right, so x cubed and x, I can pull out 1x. All right, so here, 15 goes into 5 3 times. And I pulled out 1x, so I'm left with 2 here. Minus 25 divided by 5 is 5. And here I pulled out that x, and we're like that. Okay, everything that's alike goes on the outside. Everything that's left over still stays in the parentheses right there. Okay, so see if you can do this one on your own. If you can't, go right ahead and follow along with me. Now, if you're having trouble with GCF, now the calculator, the Desmos calculator does help out with that. If you actually type in GCF of 27 comma and then 18, it will give you that 9 is supposed to come out of there. However, you've got to be able to do this on your own. X and X squared. X squared, take the smallest, all right? Just 1x. All right, both of these have y's, y to the fourth, y to the third. Take the smallest, y to the third. All right, 27 divided by 9 leaves me with 3. I took that 1x out, and I took 3y, so I'm only left with 1y. Plus 18 divided by 9 is 2. I take 1x away, so I'm left with 1x. Take 3y, so there are no more y's, and we'd leave it like that. And always double check in your parentheses that nothing is alike. All right. And this one right here. Now, the calculator, you can plug in a third number to see the GCF, but if you know it, 24, 18, and 4, a 2 comes out. All right. Each of these has x to the fifth, x to the third, x squared. How much is the smallest? 2x's. So I'm going to take out x squared. That's it. I don't have any other variables. So now I got to see what's left. Think division. 24 divided by 2 is 12, and I took 2 x's away, so I'm left with 3. 18 divided by 2 is 9, and I took 2 x's away, so I'm left with 1. And then negative 4 divided by 2 is negative 2, and then these 2 x's went to the outside, so I'm left like that. All right, so those are some review things that you've got to remember. We're going to keep building on the factoring, all right? So please make sure you understand every day we go over factoring, it's something that you got to recall for Math 1 and Math 2. Here, these were functions, inverse functions. Those will come back eventually. All right, so let's move on and let's go to our workbook right quick. And we're going to go to page 135. All right, we're going to make a box, all right? Or think about. All right, so look at this bridge. This is on page 135. Which expression correctly describes the unknown length as indicated by the question mark? Now look right here and then look right here. These are each a length of x. So here, if you think about it, this whole thing is 10 inches. But if I'm trying to take this part right here, and I would just want to find that. Think about it for a second. This much, if I take this much away, I took away x. If I take this much away, I'm taking away x. So really, this side is 10 minus 2x. All right, so now let's think about an expression for this side, for that question mark. Now notice they said from all the way from here to here is 24. All right. So if I'm taking away x here, all right, this side's going to be 24 minus 2x because there's 2 x's right here. All right, so now look at the expressions that they've written here. Now that's just 1x. See, they didn't take any x's away, and here they added the 2 x's. Here, they just didn't write it the way we wrote it. They took away the x's separately. So our answer is B. All right, so if you got B, you are correct. And anytime, please freeze this to make sure you know what you're doing and you can try it out for yourself and then check. All right, I'm going to keep going on. Now, I know this says on page 136 which one doesn't belong, but let's start thinking about some other things that we can do with boxes. All right, now, number one, just know a box, another word for box is rectangular prism. All right, so if you ever hear rectangular prism, please know that that's a box. All right, so for any boxes, if they give us all the dimensions of the sides, what can we find really quickly? We can find the volume because the volume of a box is length times width times height. All right, that's a formula that you need to have memorized. So make sure you have it memorized. All right, so here to find this volume, we would do 4 times 8 times 10. All right, so if we quickly, if you want to throw it into your calculator, 4 times 8 times 10 quickly gives us 320. All right, and when we talk about units here, as far as volume, it's centimeters cubed. All right, so here we could also find, this is the same thing, except for this time they gave us a picture. All right, here, so the volume is 8 times 2 times 10. Some of you should be able to do this in your head. 8 times 2 is 16. And then 16 times 10 is just 160. So centimeters cubed. All right, again, because this is in centimeters and our dimensions are cubed when we talk about volume. All right, This one's a little bit different picture, but again, they give us all the dimensions of the sides. So the volume is 4 times 4 times 20. All right, 4 times 4 is 16 times 20. Now, if you're doing this in your head, think 16 times 2 is 32, but then I have that 0, so I just add a 0 on the end. All right, so if you actually look at C and A, they actually have the same volume. Now, this one's totally different. This one's kind of like add a character. All right, yes, it did give us a picture this time. However, this time they actually gave us the volume. All right, we can come up with an expression of the volume. So volume is 320, but length times width times height. So I can do this x right here times x plus 1. I'm going to put parentheses around it. And then times that 4x right there. Well, what are some things we can do with this? We can actually find, and I'm going to go to my calculator on this, and I'm going to pull up Desmos, and you do the same thing. All right, so when I pull up Desmos right here, I can actually type in x, all right, and then parentheses x plus 1, and then, whoops, plus 1, all right, and then 4x. Okay, and then what I can do is I can say y equals 320. Now I have to say y equals because there's not a variable with the 320. All right, well, what are some things that this can give me? Well, here, what it can give me is the x value. If I go all the way and I'm zooming up and I'm finding where these two lines cross, okay, and right here, when the volume is 320, my x value is 4. All right, so those are some things that I can do with this and that you may see us do throughout this unit. All right, but let's go build some boxes. All right, grab yourself a regular sheet of paper. All right, I've got this. And remember, a regular sheet of paper, and I'm going to draw a picture, is 8.5 by 11. All right, so 8, and I'll say 8.5, and this is 11 inches. Okay. So what we're going to do is we're going to cut, and I'm just going to estimate some of this a little bit. And I'm going to cut out a 1-inch square out of each corner, similarly to what we just did. So if I take a 1-inch square, all right, and I'm going to cut it out. So here we go. I'm just going to make this bigger. Oops. Now you can't see me anymore. There we go. Okay, I'm going to make this bigger. And all right, so let's think about this for a second. And I'm going to, hold on. I was trying to make my picture smaller, but I don't know if it's going to. All right. So here we go. If we do the lengths right here, and I do this different sides, think about this for a second. I just took out like a 1-inch thing right here. All right, so for the length, think about it. It's 11 minus each of these ones, so that's going to be 9. All right, and then here, same thing. We took out ones here. So if I take away, I basically take away 2, I'm going to be left with 6.5. All right, well, the height, if you notice when you did this, the height of this was that 1 inch that I cut out. All right, so what's the volume of this box? All right, so all I'm going to do is multiply 9 times 6.5 times 1. All right, so 9 times 6.5 times 1 is 58.5. So 58.5 inches cubed. All right, well, what happens when I take another sheet of paper and I actually do 2 inches? Okay, so what I want you to do is I want you to put a 2 in that next box. All right, and I want you to, you're taking squares and you're cutting them out a little bit, 2 inches. All right, so they're bigger than last time. All right, what do you think it's going to do to the volume? All right, we're going to figure that out in just a second. All right, and if I fold it back up, all right, and mine's not the greatest, yours might not either. All right, it appears our box is smaller, but this time it's taller. Okay, so think about measuring. I just took off 2 inches on this side and I took 2 inches off on that side. So think if it was 11 and I took 2 here and I took 2 here, what's it going to be? All right, well, that's going to be 11. Think about it, 11 minus 4. All right, that's going to give us 7. All right, now let's think about this side. Well, it was 8.5. Well, I took 2 off of this side and I took 2 off of this side. So I took a total of 4. So this is going to be 4.5. All right. Or you can measure it and actually see. Well, what's the height on it? Well, the height was that basically the inch or 2 inches that I had cut out. All right. So we're going to write 2 right here. So what is our volume? So when we do 7 times 4.5 times 2, it comes out to be 63. So we actually increased our volume by doing that. All right, so we got a question down here. The volume V of x in cubic inches of the open top box is a function of the side length x in inches of the square cutouts. Make a plan to figure out how to construct a box with the largest volume. Well, the first thing we've got to do is we've got to write an expression. Well, just think about it. The height was always what we cut out. We'll call that x. All right. And then here for each of these, we always took 11 and we minus 2x here. So that was 2 times 2. This was 2 times 1 up here. And then we always took 8.5 and we minused 2x again. All right. So there's an expression for our box for the volume. All right. So we're going to move on. And so that was page 137. Let's move on and flip over to page 138. We got some questions for this. Now, they wanted us to write an expression then. All right. We already wrote our expressions, so I'm going to rewrite it right here so we have it on this page. All right, using a graphing technology to create a graph representation, approximate the value of x that would allow you to construct an open top box with the largest volume. Now, unlike that little warm-up thing that we had in those boxes, and I graphed it just a second ago, and it had looked like this time what we've got, they didn't give us the volume. I'm just going to put x and then 11 minus 2x and then 8.5 minus 2x. All right. So we want, and the key is, and I want you to circle this word, the largest, or highlight it. We want the largest volume. Okay. Now, here's some things. What can X not be? All right. And we can start talking about the domain of this right here. Okay. So think about this for a second, like 5.5. All right. Well, think about this. If X was 5.5, all right, 11 minus 2 times 5.5. Do you see how that comes out to be 0? All right. That means that side would be 0 right there. We don't want that. Okay. We also notice down here, the volume gets to be negative. We don't want the volume to be negative. All right. We want the volume to stay in the positive. So I just really want this first part to where it hits here. And really, it can't even be 4.25 because right here in the 8.5 minus 2x, if I put 4.5, that one goes to 0. All right. So here, there we go. Right here, all the way to this amount. We said 4.25. All right. What is a reasonable domain? All right. I don't want to include 4.25. And I also do not want to include 0 either, because 0 means we didn't cut anything out and we don't have any height. All right. So I'm not going to put equal to. Another way to write it is 0, comma 4.25, like that. All right. Okay, now what is the largest volume? Well, when I go and actually look at the graph, think largest is the highest point. Well, the highest point right here is this point right here, okay? Here, what that point means, and I'm going to write it down. I want you to do the same thing as well. And this calculator has rounded this, all right? Here, if you notice the X, this is the X. This is what we would pull out. So this is the X value, basically in inches, that you would want to cut out of each corner. All right, that's the size of each of the squares on either side. This is the max volume that it's going to give you. That's the highest this volume can have with this size piece of paper. All right. Okay, so let's move on. And I just want on page 138, I just want to do one more question. right here. It says the surface area, all right, the surface area in square inches of the open top box is also a function of the side length. Okay, so what is surface area? Surface area is the area of all sides added up. All right, it's like taking each of these boxes, and I could take this rectangle and I find the area of it. Take this rectangle, find the area of this. Take this one, area, find the area of this, and also find the area of the base, and I add it all together. All right, so let's think about this for a second. To find the area, all right, of the sides, um, think about it for a second. This one side is, all right, the height is just x. All right, and this is going to be 11 minus 2x. Oops, 11 minus 2x. All right, this side right here is going to be an x, but this is going to be 8.5 minus 2x. All right, this one is going to be the same as it was on the other side, 11 minus 2x, and that's x. All right, and this is going to be the same thing on the other side, 8.5 minus 2x, and then the height is x. All right, now the base, this is 11 minus 2x, and this is going to be 8.5 minus 2x. So you got to find the area of each one of these. Well, the base, there's only one of those. So it's going to be 11 minus 2x times 8.5 minus 2x. Now, I have two of these small rectangles right here, where I just multiply x and 8.5 minus 2x. And then I have two of these rectangles right here, where it's x times 11 minus 2x. And guess what? I just made an expression for the area, all right, of our, or the surface area of our figure. So that's thinking outside the box for it. All right, so let's move on. Okay, and we're going to do some practice problems as well. All right, so I'm going to create that in another video. So I want you to follow along with me in the next video and do some practice problems along with me.